My name is Sandrine Bayard, I'm 17, I'm from Port-Cartier in Quebec, and the title of my project is Le Pansement qui pense, which means the thinking bandage. My grandmother had 2 years ago second-degree burns from dropping a hot tea on herself, and she tried a long-term bandage.
So current bandages are designed to last a long time on these wounds, or such as a burn, but they don't really allow you to detect any sort of infection.
At the end, we removed it to see if it was completely healed, and we saw that there was an infection and it was too late. And she had to start the treatment all over again.
Her idea was, could you use the Band-Aid in such a way that you can actually measure to see whether there's any infection there or not?
She infused graphene, which allows electricity to flow through it, and based off the resistance to electricity that bacteria hold, she's able to tell whether or not your wound is infected.
I noticed that the more of the bacteria is on the bandage, the more the conductivity increases, so I can detect if there is an infection or not without removing the bandage.
We recognize that young people have great, fertile, creative minds.
And unlike many of these projects, they come out of someone looking at a problem and saying, I think I can do better. I think I can do something here.
I'm really proud of having a very small idea and that became so big, and that people are interested in my idea and think that I made something great.
Hi, my name is Gashan Tanakon. I'm from Ottawa, I'm 17 years old, and my project is called Carrier-Enhanced Evaporative Preconcentration, a novel approach for trace elemental analysis. My project was based around trace elemental analysis, which deals with the identification of substances that are found at very, very low concentrations within a given sample. Let's say that substance was a toxic metal, arsenic, mercury, lead. All those have known detrimental physiological effects on the human body. Our current sample preparation techniques are focused around bringing natural samples. So when we collect a river water sample, we bring that as is to the laboratory. So I realized that what if there's a method by which we can remove everything we're not interested in and just keep the trace elements?
He developed a way of adding a certain solid, in this case fine silicone, in order to trap all these trace elements.
And so you flow the water through the silica gel, and these atoms cling to the silica gel. So now, instead of several tens of gallons, now you have a few grams of silica gel. It's much easier and cheaper to ship those off to a lab than it is a large tank of water.
Well, innovation in Canada keeps us competitive. It's just important for people to know that that innovation is Canadian.
It's quite unknown how it's going to work out, and if the amount of time I put into it was going to be worthwhile. I'm honestly more than happy to say that it's worked out, and there is a lot of promise to the technique.
My name is Samna Aziz. I'm 17 years old. I live in Hamilton, Ontario, and the title of my project is Investigating Ceramic Calcium Phosphate Cement as Bone Replacing Material.
She came up with a new type of bone cement that is not acrylic, but ceramic.
The new idea is that we're going to create a new cement that's calcium and phosphorus based that will be injected into the trabecular bone, and it'll have a reduced mechanical strength as well as being biocompatible and degradable.
What she was able to do is first come up with a compound that is much closer to bone in its strength. But the other idea I found very intriguing indeed was that this new material slowly dissolves. So when you join the two together, the bone gradually grows and reforms, and gradually the glue goes away. I thought that was so neat.
From there, her inquisitive mind went forward and she learned more about bones and glues and all the rest of it and came up with this new approach.
So I've always loved medicine. I can't look at blood, it's not something that I can do. So I loved biomedical engineering this way because you get the medical application while using math and science. It's just something that I feel like was very inspiring, and that pushes you to keep on working on something like this on top of all the schoolwork that you have to do.
Hi, my name is Dan Alfarov. I'm 17 years old and I'm from London, Ontario. The title of my project is Using the Perception of Facial Emotions to Aid in the Diagnosis of Mood Disorders.
The premise behind my project was to look at a new way to diagnose mood disorders based on how much attention our brain devotes to different faces.
And he had a really clever idea, and the clever idea is this, that you show the happy face in one eye, and you show a neutral face in the other. And he set up a system in which he could measure the amount of time that the brain was processing the happy image and the amount of time it was processing the neutral image.
And what I found is that there's actually a unique level devoted to each phase. So you see happy for a certain amount of time versus a different time for surprise.
And his idea is that we might be able to use that as a diagnostic tool for people who have mental illnesses.
Globally, there's over 1.8 billion people who suffer from mental illness. And the issue is so large, and I think our diagnostic process is so lacking in that it looks at only the subjective psychology, that we have to bring in objective neuroscience background, which is what I tried to bring to the field.
They were not shy about going after any help that they needed to probe the particular issues that they chose.
It's not necessarily the awards, but it's the experience. It's what I've learned from the journey.